Hello everyone. It is again Moni here, and today I'll be talking about SQL. You already know that SQL, which means a structured query language, it's being the de facto standard. That means SQL is widely accepted and used as a standard language for managing and manipulating relational databases. Even though it might not be the only language available, but it is the standard. That means 80% of the time you will find a language which has been used. It is SQL. So it has like wide adoption, interoperability, standardization, functionality, and there are a lot of resources available online to know, practice, and learn SQL. So let's begin. We all are interested about data analytics nowadays, right? We talk about data scientist, machine learning. So these are all kind of the part of a data analytic process. So what happens in the data analytics process? People ask questions, right? Whether it's your business, or you are developing something, or you are doing some scientific research, all you start with a question. Like for example, what's the sales figure? Where should we focus more on the profitability for our next venture or next product or next campaign? So it starts with ask a question, as you see over here, like step one. Then to answer that question, you need to acquire data from whatever available, right? You go to different systems and extract the data from there. You can do survey. You can have like quantitative or qualitative, different kind of information you collect, right? Then you need to transform them, because not necessarily in the form you get the data that's going to be useful for you. So you need something to transform the data you collected, so that you can use it and analyze it to your system. So that goes to our next step, analyzing the data. So then you apply different techniques, which may be coming from data statistics, could be some business. um, so um, so they will give you the high level findings, or which is in the step 5, and that basically gives you the answer to your question. But again, you see, it's a cycle. That means it can also raise another question. Like for example, okay, we should be focusing on say this particular area for our sales, next year sales, but which product we should be focusing on there? Like in that area, customers must be like have interest more in some product than the other. So that means we need to also focus on these areas, right? So this is the cycle we go through. And interestingly, in all the way through this cycle, you can have access to relational model data, and the things you will be trying to get answers from, and all other activities you will be 80% of the time, right, you will be probably using SQL for that. So relational databases, we already know that relational database consists of a table, which is the basic unit of data storage in a database. Data is stored in rows and columns. You can specify rules for each column, that we call them the constraints. You have the domain, which is basically the data types, forcing the column to contain a value in every row, or you can have nulls. Then there is view, which is tailored presentation of data selected from one or more tables. It is just like you're creating another table from multiple or one table based on your requirement through a query. So that's what we call view. Um, and you can consider like view as a virtual table, which does not exist if it's not materialized, but you can query that view, right? The schema, which is also very important, is a container within a database, similar to a directory on a file system, that groups tables together. The connection between tables is made by a primary key, a foreign key pair, where the foreign key in a table is the primary key of another table. So if I have an employee which has a column which is a department, and department can be a department ID, which is existing in the employee table, which can be a department ID can be a primary key for a department table somewhere else, right? So there goes a primary key from the employee table to the department table. And finally, one of the most important thing, which is the query, right? A structured query language, SQL. So query is there. A query is used to create, manipulate, or view database objects. And of course, like to present them, you need reports. It's a formatted view of the data from databases within the user-defined parameters, often generated in an external file format such as text or PDF or image, right? So the relational database is a collection of data that are organized in tables and maintains relationships between the tables for information retrieval. And we call the RDBMS, which is basically the Relational Database Management System, is a computer software that enables users to create, modify, and analyze data in a relational database. Enterprise relational database management systems includes like SQL Server, Oracle, MySQL, DB2, SAP, Teradata, PostgreSQL. So these are basically enterprise level relational database management system. But sometimes to learn the SQL and do our small scale works, we use lightweight relational database management systems, which includes Microsoft Access, which is very common if you are a Windows user, or SQLite, which is much more raw SQL command line based database system, which is very small size embedded systems. Embedded systems sometimes use this database. It is not like visually heavy like Microsoft Access. Both of them are lightweight, but SQLite is more lighter. So we know the tables, right? The tables consist of one or more records or rows of data. The data for each row is organized into a defined set of attributes organized into columns. Data type can be of different, like string, text, character, numeric, which can be like of integer and float, date and time, boolean, yes, no, true, false. As you can see in the example, you have customer ID, company name, contact name, and contact title. So these are different columns of the same table. We call customer ID, looks like all of them are a string here, right? Or text. So relational tables, a customer ID, if it is a number, say integer, cust ID in the left hand side, as you can see here, which can be 1, 2, 3, 4, 5. These are primary key of this table. So you have a say customers table, as you can see over here, customers table. It has customer ID, first name, last name, and email address. And to identify each customer, we are using each row with a key, and we are calling this attribute cust ID as the primary key. So now if you have another table, just like we explained before with the employee table and the department, same way you have orders, right? So one customer can order something, and so this is the order ID 1. And which customer did that? Like customer 2, which is Steven, and what the date and which date and what was the amount. So as you can see, the order ID is the primary key for the orders table, but which customer, this is the foreign key. That means it's a foreign key for orders table, but it's a primary key for customers table. So this is how the relationship is established between the two tables, orders and customers. And it is very much common in relational databases. So primary key, it's a unique identifier of records in a table. Primary key values may be generated manually or automatically. A primary key can consist one or more than one field. We call that composite keys. So why this is important? Because anytime you want to find any record from a table, you need to identify uniquely one of the rows, right? One of the records. And to do that, you need the help of primary key, like how you are going to identify like this row is unique. So that's where the primary key comes to play. As you can see, the athlete table, you have ID, name, country, phone number, email address. The athlete table ID is something which is unique. That means no two items or no two records in this table have the same ID. It is always unique in this column. So let's look at some foreign keys. So you have athletes and you have some events. So athlete ID, which is the primary key for the athletes table. In the events table, event ID is the primary key, but athlete ID is the foreign key. So basically they are communicating with the um, primary key of the athletics table. So primary key field athletes ID, parent table is the athletes table. You have child table which are events. They have relationships based on foreign key and primary key, and you know athlete ID is the foreign key here. Relationship types. So we know that there can be one-to-one relationship, one-to-many, and many-to-many. One-to-one, each instance of one entity relates to only one instance of the second. So that is one from this table to one from another table, one-to-one. Not frequently used in database systems. Might use to divide a table with many fields in order to isolate part of a table. We'll talk about these things when we will study normalization. So what is one-to-many? Each instance of one entity relates to one or more instances of the second entity. Most common type of relationship, and it is used to relate one record from the primary table with many records in the related table. In a one-to-many relationship, a record, say parent in table A, can have many matching records childs in table B, but a record child in table B has only one matching record parent in table A. Many to many, multiple instances of one entity relate to multiple instances of second entity. So we also study the entity relationship diagram. So this is basically when we are doing this, we have to follow this grammar of entity ER diagram, right? This is how we do that. So this is done in a way like you have, say, season ID, that is the primary key, which is at the top. You have season, and that's like one to many relationship, right? Can have inventory. Then you have, say, unit ID. So these are the symbols, 1, 1, 2, 0, or many. So this is how we just relate from one table to another, which is basically the primary key to the our foreign key. So now this is the important part of this talk, the structured query language, SQL. So SQL, a structured query language, is the programming language used when interacting with data in a relational database, right? Not NoSQL or MongoDB or Neo4j or Cassandra. Okay, so SQL implementations for different databases may have minor differences in functions and syntax. SQL statements can be categorized into two groups, like data definition language, we call it DDL, and data manipulation language, DML. DDL statements are used to create and to alter table structure in a SQL Server database. Like you want to create a new table, you want to add a new column, that's how we do it through the DDL, right? But DML data manipulation language statements are used to add, modify, query, or remove data like the records from a SQL server or MS Access or SQLite databases, right? So SQL basics. So SQL basics, here we're going to study the different items which are associated with SQL. So when you say a statement is a complete sequence of functions, keywords, operators, and values that can be evaluated by the database engine. A query returns records from one or more tables in a database. A clause is a component of a statement or query. An expression is a combination of one or more values, operators, and functions that evaluates to a value. Extra white space, spaces, newline, etc. is not evaluated. SQL is typically case insensitive, but functions are capitalized by convention. SQL statements are often required to end with a semicolon. So we look into the statements, but you know there will be a statement, query, clause, and expressions. These are the things that will come frequently when we talk about SQL. Select a statement. A select statement is used to fetch records from a database table in the form of a table called a result set. One or more columns may be specified, or the asterisk can be used to return all records from the table. Use the limit keyword to return only the first and n rows from the result set. So if you want to return like only the 5, you can do that limit 5. Here is the example. The result set is not stored in the database without the use of additional functions. So you can say, like, for example, select column 1, comma, column 2, column 3 from that table name, or you can have select star, that means all of the columns from that table name. Select column 1, column 2, column 3 from table name, and you can say limit 5, only 5 you want to see. So create table statement is used to add the result set from a query to the database as a new table. Complicated queries can be broken down by creating intermediate tables. The ability to create a table depends on the level of access granted to a user, so it may not be possible in some situations. So you see, we can see right, create table, new table, as select column 1, column 2, column 3 from table name. So from the table name, we are creating a new table. That's name is new table. Order by, it is also very important. The order by keyword can be added to a select statement to sort the records. The typical default order is ascending order, but you can also specify descending. Say select column 1, 2, 3 from table name, order by column 2, 1, and 3, descending order. You can have count. The count function returns the number of records in the result set. The input parameter can be star or 1. Like select count star from table name, select count 1 from the table name. Where clause. The where clause can be added to a select statement to filter records that meet certain conditions that return a subset of the table. We use expressions to define these conditions. Most conditional operators are self-explanatory, like equal to, smaller than, greater than, etc. A common operator for not equals is it's like smaller than, greater than combination, or explanatory and equal. Say select column 1, 2, 3 from table name, where column is equal to ABC, where column 2 is greater than 100, or say column 3 is not equal to 0. These are some examples. So comparative operators, right? You have equal to, so they check whether A or B is, say A is 10 and B is 20, as you can see in the right hand side of the example. So that statement A equal to B is not true, because 10 and 20 are not true, right? If you use not equal to, if values are not equal, then the condition becomes true. So if the condition is A not equal to B, yes, this statement within this, you can see the parenthesis, is true. This one is not true because A and B is not equal. Then check if the two values are not equal, they are using just another syntax. It is also true. A greater than B is not true because A is 10, B is 20. But B greater than A, yes, it is true. So and or. So as you see that we sometimes need to do, like A is greater than B, but A is also smaller than C. So that is where you need in the clauses the and or, these things, right? So an and or operator can be added to a where clause to filter records based on multiple conditions. And the and operator returns all records where both conditions are true. Both conditions have to be true. The or operator returns all records if either the first one or second one or any one, either of the first condition or the second conditions are true. So here is the example. Select column 1, 2, 3 from table name, where a condition and another condition. So you have two conditions, a condition and another condition. Select column 1, 2, 3 from table name, where a condition or another condition. So the previous one was and, like here the both condition have to be true to get this answer selected. And for the second case, either of them is true. If either of them is true, then this select command will be executed. In is another one very important. The in operator can be used to specify multiple values in a where clause. This is equivalent to a series of or clauses, like whether this one or this one or this one or this one or this one is equal to some value, right? For example, select column 1 2 3 from table name, where column 1 in value 1 2 3 value, and so you can say that, okay, if something is within 1 to 5, so you can write if the column value column 1 is in 1 2 3 4 5, then return that result 1 2 3, right? You can do that. You can use also similar thing. In can be replaced with the or, like where column 1 is value 1 or column 2 is 1 is value 2, and or and it goes and goes and goes until column 1's value is n. So between operator can also be used in where clauses to select values within a range. Like you have select column 1, column 2, column 3 from table name, where column 2 between value 1 and value 2, where column 2 is existing there, right? So between is saying that whether it is within that range, you can provide that range. Like operator, it's mostly used with the text or character, can be used in the where clause to search for a specific pattern in a column, like support several wildcards. Like select 1 to 3 from table name, where column 2 values are like value 1 is somewhere. This is the value 1 is part of the string. It's a substring. So wildcard person means a substitute for 0 or more characters, underscore for a single character. Character list sets and ranges of characters to matches only, the last one is matches only a character not specified within the bracket. Null and not. So null means that a value has not been entered for a particular column in a row, that the value is missing. Null is not numeric or any other value, so it can't equal itself or anything else. Not creates the negation of an expression. To test the null value, you will want to use expressions is null or is not null. So you can write select column 1, column 2 from table name, where column 2 is null. That means no value is there. By the way, you should know that the primary key cannot be null by default, because primary key has to be there to identify a record. So if it is null, then you will not be able to retrieve that data. Okay, so the second example is about is not null. Expressions. An expression is a combination of one or more values, operators, and SQL functions that evaluate to a value. Anytime the data must be displayed, filtered, or ordered in a way that is different from how it is stored, you can use expressions and functions to manipulate it. We can use expressions to create calculated or derived fields, as in the example, like end underscore BAL minus BEG underscore BAL is the expression. So there is something end, beginning, and balance. BAL is the balance here. Yes, I think, yeah. The example shows about the balance. So the ending balance and the beginning balance will show you like how much money has been added or taken out from there. So minus is an operator. End balance and beginning balance are columns in the existing table. As difference provides a name for a new column in the result set, we can write select column 1 end balance minus beginning balance as difference from table name. So you can also do that. So arithmetic operators, you have plus, minus, multiplication, division, and this one modulus, right? Remainder, yeah. Strings. So the R trim and L trim are functions that removes the right side or left side of a string if there are wide spaces. So use substr to return a portion of the string starting at a position or for a given specified for a specified number of characters. So substring, string, start location, and length. Like you get goodbye, starting location can be 0, that is G, and you take 4, so GOOD. You just, from goodbye, you just extract good. So use the length to return the number of characters in a string. Other SQL implementations may use alien. So that is also another way you can use that length of a string. Okay, so string functions, so you can have upper and lower to change a string to either uppercase or lowercase. You may need to display all uppercase data in a report, for example, upper and lower of a string. Use replace to substitute one string value for another. Use replace to clean up data. For example, you may need to replace slashes in a phone number or column with the hyphens for a report. Then you can write replace string value, the current string value, a string to replace, and the replacement. So like select column 1, replace column 1 in the column 1. So the string value is the column 1, and then string to replace, you have a slash, and you have to replacement with a dash. So you can write that column into new column, and it will be applicable for the whole column from the table name. Numeric functions. All right, so numeric functions. So we used round to specify a number of significant digits. Like select column 1, round column 1, 2 as new column from table name. Use so you see the column 1, we are rounding it up to 2. Like for example, if it has more than say 32.5678, so I want to take only 5 and 6, 2. So I can write round column 1 up to 2. So use random in combination with the absolute value function abs and modulus operator to generate random number on a specific range. Like select all, then abs random from like 100 value of 100, and then you generate as a new column from the table name. So that is what you can also do. Date function, which is useful in many cases based on the way you enter data. Like different SQL implementations have varying functions and operators for dates and time. Like for example, SQLite, which is the another lightweight database. Date objects are created by date and related functions, and arithmetic operators are used to do calculations involving dates. So and date now returns the current date and time of the server. Julian day interprets dates in the standard 4y, month, and dd format. String function time, flexible time, right? String flexible time provides flexible options for managing dates and times using substitution shown at right. So these are not very common. We mostly use date now. So as you can see over here, that sub percentage d, date of the month, f fraction seconds, ss starts sss, hours, day of the year, Julian day number, month, minute, hour, minute, second, since some date. So these are the examples what you can expect. So we can also do some masking on top of that, like how you're gonna see or present the dates. We will look into this that shortly. All right, so after the date functions, we are moving towards the example. So for example, you have select Julian day now, so that it will take the system time from your computer or online if you are. So minus the Julian day, 1776 as 0704. Select column 1, string, then you do format the time in the column 1, and you call it a new column. Same way you keep on doing for and from the table. So it will just modify, give you the current date minus that 1776 and give you the result. Okay, so in this way you can format the dates. So casting is another thing. So the cast function is used for explicitly changing the data type of a column, often from like text to numeric or vice versa. Available data type includes say integer, character, text, real, float. So you can cast say a column 1 as integer column from table name, uh, as column 2 as character. So regardless of the column 1, it can be say number or character. You can cast it in integer. So distinct is another function which actually gives you a set value rather than multiple vague values. So the distinct function returns the unique values in a column or unique records across multiple columns. So you can have one value repeated several times, but if you want to get the only distinct ones, unique ones, you can do that. So then a combination of count and distinct returns the number of unique values. So select distinct column 1 from table name, or you can use like select count. You are using count function on top of like the distinct columns, right? And from the table name, you can do that also. Aggregate function is sometimes used and very useful. It includes count, as you have already seen, calculate the total or statistics by column. This is statistics can apply to all rows or groupings of rows using group by. Yeah, other SQL implementations may include additional statistics like a standard deviation, variance, median, etc. So you can see in the left hand side you have count, sum, average, mean, max. So group by clause, how do we use that, right? So the SQL group by a clause is used in collaboration with the select statement to aggregate by groups. It is similar to the Excel's pivot table. So the group by clause follows the where clause and precedes the order by clause if present. This clause regularly makes use of the SQL's aggregate functions. When used by group by, each aggregate function produces a single value for each group. Say, for example, select column 1 to count 1 as CT, sum column 1 as sum1, then from table name, where a condition which is true, group by column 1 and column 2, or order by, and also including order by column 2 and column 1. Examples of the group by with aggregate function. So you have this table where you have order ID, custom ID, like so which order, which customer have placed in on which date, and the amount. What is the amount, right? So you write select. So you select customer ID, second column, sum of the amounts as total amount. So you see you are doing group by customer ID. So that means there will be several customer IDs. There will be several customer IDs in this column with the same value. Say customer 2 is appearing here in 1, then in 9, and in 12. So you want this 1, 9, and 12, all these amounts to be summed, like 100, 0.22, 355, and 130. So these are all summed into this, right? 585. So you select customer ID, sum of the amount as total amount. So you're renaming this as total amount, which you can see in the result set, second column. Then from orders, this is the order table. So it's grouped by customer ID and order by total amount, descending order. So that means it's going from the highest amount of the total to the lowest one. This is one of the most used queries in the SQL you will see. The next one is having clause. So sometimes that's like where sometimes we use having. The having clause can be added to group by to filter records that meet certain conditions. Return a subset of the groupings. Operators are the same as the where clause, right? We just said. So select say column 1, 2, and count 1 as counts from table name. Group by column 1, column 2 having that counts the value should be greater than 5. Same way, group by column 1 having counts greater than 1, and sum 2, which we used in column 2, is greater than 10,000. Case is another option, which is we use the case function to evaluate a list of expressions and return the first one that evaluates to true. Case can be used inside aggregations to generate a statistic like sum only for the certain records. Here's an example. Select column 1, column 2, case, test expression, like you test something is greater than or smaller than. When comparison, then return the value. When comparison, another one, like then return something value, and else the default value. It is almost like the similar thing you have seen in any other programming languages like C, C++, Java, C Sharp. They have this notion of case or switch over there. So and as the new field name from table name, select column sum. You can again use case and from another table. So this is another example. So join clause. So when you are using the keys, primary key and the foreign keys, you can use joins to get data from the tables. So join combines fields from two tables using a key column shared by the tables, right? So select table A dot column 1, table A dot column 2, table B column 3. From table A, how we are getting the data? Joining table B on table A dot column 1 equal to column B, table B column 1. So that means these in table A and B, column 1 is the primary key to and foreign keys connection. Aliases. SQL aliases are used to temporarily refer to a table or column by a different name. Aliases are commonly used in join clauses to save spaces and keystrokes. Like select employee dot business entity ID, first name, last name, job title from human resources dot employee, inner join, something like that, right? So you can do it in a sense like E. Instead of employee, you can write employee E dot business entity ID, first name, last name from human resources employee as E. So you're just calling human resources dot employee as E, and you can use E everywhere. And P for like person as P. So these are the some important join mechanisms. Like inner joins, if you have like two sets of data, selects rows from both tables as long as there is a match between the key columns in the both tables. So this green part is showing which it's gonna pick when you do inner join. Left join returns all the row from the left with the matching rows in the right table. The result is null in the right side when there is no match. Similar is right join. Full outer join returns all the rows from the left table and from the right table. The result is null if left and right or right when there is no match. Okay. So you see some examples. So you have customers, orders, and you know the connection. So when you do inner join, it gets all the common ones, right? Customer ID 1, 2, 3, 3, 4. So 5 has not been present in the orders table. So 5, when you join them, customer ID connecting with the order table, 5 has no match. So you only get this data. Left join, you get all the things from 1 to 5 from the left table. Where there is no data available in the right side, you get null. The right join, you get all the things from the right table. Say you have one order for customer 7, which ID is not present here, or order ID 6, so it will show 0 here, but null here in the first name and last name. And full outer join is a mix up of both, where you don't have the present data, you get null for those. Join with group by. So this is another example. You have orders and customers, right? So select order using aliases, order as O, customer as C, last name, first name, inner join, you see customer as C over here, on when the client ID in order table and the customer table is the same. So you group by them, customer ID and first name and last name, then order by total amount in the descending order, and you can also do that. So and you see the results, the 7. For 7, the first name last name is null, because customer ID 7 is present here, but it's not present in the customer table. So combining queries. Select statements can be combined to avoid hard coding values or creating intermediate tables. In a simple case, an additional select statement returns a value for use in a condition. Like select all from table name where column 1 is greater than select average of the column 1 from table name. So if you want to calculate the average first on the column 1, you can do that, and you can feed in into this where clause where the column 1's value is greater than all the average one. So basically on column 1 you are getting all the data which are greater than the average. So this is basically working 2 times. First it's calculating the average, and then it is using in another query to get all those values which are greater than the average value. So more complex queries with multiple layers of nesting may require the use of the aliases. You can also call like this column name as temp, and you can select from temp, right? So these are some good examples. So in the summary, you know that you have to, for data analytics or data, you have to go through the access to the data. So how do you are going to acquire the data? You have to access it, connect into a data source, import the data, read the data into an analytical environment, then data profiling, review data dimensions and summary statistics like count, distinct, mean, max, sum, average, order by, group by, these things. Data quality assessment, identify aspects of the data that pose challenges for subsequent analysis. For example, sometimes if some data is null or is not null, that can be a big factor in your analysis, right? So, and data simulation, generate data based on analytical requirements. In SQL, you use random. So for transforming data, cleaning data, address data quality issues to facilitate the analysis. You can you can clean, like trim from the left side, right side, upper, lowercase, uppercase, round some figures in the numerical values. We have seen these things. Okay, so changing data types, you can use cast. Filtering data, you can use where, having, in between, liking. Deriving data, replace substring, Julian name. Scaling data, you can do mean, max, average. Sampling data, you can use the random. Aggregating, you can use the group by. Reshaping, you can change, like drop columns and add another column. You can concatenate data through union all. Merge data through inner joint, left joins. For analyzing, you can use this SQL like mean, max, sum, average, and you can do other tools for statistical analysis, clustering, network analysis. To present the findings, you need data visualization. There are a lot of tools available. Like you can use Python. Some people use R. Julia is also there in the market. All of them are free and open source. You can use dashboard like W, report, exporting the data, and also making recommendations. Like based on your analysis, you can present your results. So that's all from now, and you hopefully you understand the basics of the SQL. You practice it, and you will be able to do these tasks very smoothly and fluently. Thank you.